All right, today we're talking about atmosphere video 2. So we're going to talk about chapter 18, moisture, clouds, and precipitation. So the first section of chapter 18, and we will do all of chapter 18 today, is water in the atmosphere. The first thing you need to know is the definition for precipitation. That's any form of water that falls from a cloud. So that could be in the form of dew, mist, fog, rain, hail, or even snow. Now, when we talk about all these various types of precipitation, each of them come in a different change of state or state of matter. So solid, liquid, or gas. So let's talk about how changes of state move from one state to another. So from solid to liquid, let's say melting ice, such as the images you see at the bottom of the screen, it requires energy, or what's called heat. So you raise the temperature, solid to liquid, melting occurs. The actual term for this heat, or this energy that's required, is latent heat. It's any of the energy that's absorbed or released during a change in state. Now, a solid to a liquid is not the only change in state that we have. We also have a liquid and a gas. You can move from a liquid to a gas, or the opposite, a gas to a liquid. Evaporation is the process from a liquid to a gas. So you have a cup of water sitting on the table. Over time, it will evaporate, and all of that water will turn into a gas, and the cup will be empty. The opposite of that, condensation, in the air we have water molecules, and these are in the form of a gas, so water vapor. So once this starts to cool down to a certain extent, it's going to reform from a gas into a liquid. And that's what you see in that bottom image. You can see those water droplets on the outside of that liter Coke. The third one is solid to a gas or gas to a solid. A sublimation, that's the change of state from a solid directly into a gas. Okay, so you can see that in the images off to the right there. There's no liquid state with these. So it's completely bypassing being a liquid and going directly from one to the other. Deposition is the opposite of that. You have a vapor or a gas that's changing directly into a solid. So again, no liquid state is there. So for examples for sublimation, think about dry ice. And for an example of deposition, think about frost that you have on your vehicle, especially this time of year, right? So just to recap really briefly, sublimation, melting, and evaporation, all of those require heat to be absorbed into them. So it requires a raise in temperature for those to occur. And then you have freezing, condensation, and deposition, the opposite of the first three. Those release heat into the atmosphere because they need to be colder in order to have those things occur. All right, a few terms that you'll need to know. Humidity is the first one. That's the term for the amount of water vapor that you have in the air. And you can have a saturated humidity. So you have the maximum quantity of water vapor that the air can hold in the air. So that would be, let's say, 100% humidity. I know you guys, if you ever watch the news or the weather, where it comes on talks about the humidity for the day, it might say 91% or 75% humidity. So let's talk about what that exactly means. So relative humidity is a ratio. It's the actual amount of water vapor that the air has in it to the maximum amount of water vapor that the air could possibly hold. So if you take a look at the image at the bottom, you can see that at 10 degrees Celsius, it's 100% relative humidity. What that means is that the actual amount of water vapor in the air is equal to the maximum amount of water vapor in the air. Okay, so it can contain, there's no more water vapor that can be put into the air unless some of that comes out as a liquid or a solid, just like we talked about previous couple of slides. Moving all the way to the right, you can look at the 30 degrees Celsius. And again, temperature has an effect on this. We have 28% relative humidity. So that means that the amount of water vapor in the air is only 28% of what it could be. Okay, so when we say 91% relative humidity or humidity in the atmosphere, think about, okay, there's 100 grams or 100 water molecules in the air, we have room for 9 more if it's 91% humidity, okay? Dew point is something that goes along with humidity. Dew point is a specific temperature that you need the air to be. It has to be cooled down to that temperature in order for saturation to occur. So that means in order for it to reach the maximum amount of water vapor it can hold in the air, there's a specific temperature for that. And anything that's left over is going to come out in the form of dew, as you can see in the images. All right, section 2, cloud formation. There are certain processes that lift air. The first one we're going to talk about is a front, and that's a boundary between two adjoining air masses that have contrasting characteristics. So they're opposite in characteristics. So if you look at the image, you have a cold front pushing in, a warm front coming in as well. And there's kind of this imaginary boundary or divide between those two. And warm air, of course, is going to be pushed up. So that forces that air to lift. Other processes are orographic lifting. So if you take a look at the image on the left, you can see that there's airflow that comes in. It's pushing those air masses up toward the top of this mountain range. And then once it clears the top, it's going to plummet back down into that rain-shadowed desert area. Okay, so it's orographic is pushing it up and over based on the geography of the area. The other is frontal wedging. As you can see, it kind of looks exactly like a wedge on the picture on the right. So you have warm air coming in, cold air coming in. And again, warm air is the one that rises. So that warm air is going to push up. It's going to push those clouds up. But it's going to kind of form this wedge shape. So it's going to move up at a diagonal instead of straight up into the air. Other processes, we have convergence. This is where you have airflow that comes together and they will rise toward the top. So if you look at the image, you have two converging winds. They come up, they lift, and that cloud gets pushed higher into the atmosphere. Condensation is a very important term. When we talk about what's in the atmosphere, you have to have a saturated atmosphere in order to get condensation. So again, referring back to that dew point from the first section. And there must be a surface for that water vapor to be able to condense on. So leaves, grass, vehicles, windows, all of those things are surfaces that the water vapor can cling to and form condensation. And we have what's called condensation nuclei. So these are tiny particles that the water vapor can condense to. So you have all these tiny particles that kind of start forming together to build up this water molecule. Because if you think about the size of an atom, it's very, very small. Okay, so keep that in mind for condensation in the atmosphere. Last section is cloud types and precipitation. And I know I'm kind of moving fast, but again, you have the ability to pause and rewind if you miss something. Cloud types, we're going to talk about 9 specific types of clouds. You can see them in the image here. But let's go ahead and talk about how they're classified first. Clouds are classified by how they form, that's the first thing, and their height. And it can be based on either one of the two, but let's start with how they form. So cirrus clouds, so this is how they're forming. Cirrus is the term that means curl of hair. So these are clouds that are very high, they're very white in color, they're very thin, they're kind of wispy, okay? So if you look at the image here, you can see that they are very wispy, very thin, kind of just like tufts of hair at the end of your head of hair. So cumulus clouds, that's the second type. Cumulus just means a pile. So these clouds are just literally just piled on top of each other like a big bowl of cotton balls. They're rounded and they are individual masses. So you can have smaller ones, you can have larger ones, but they are going to be piled on top of each other. And stratus clouds, stratus means a layer or what we call a sheet. So a sheet or a layer is going to cover majority or pretty much all of the sky that you can see. And you can see those pictures off to the right there. So again, cumulus clouds, those are the ones that are piled, kind of big puffy things. And then stratus clouds, that's the sheet or the layer that kind of covers the entire sky. All right, moving on, we're going to talk about the height that clouds form at, and this is different for each cloud. So the high altitude clouds, those are the cirrus clouds. Those are going to be at the very top. So we have cirrus, we have what's called cirrostratus. Those are flat layers of clouds that are still very thin. And then you have cirrocumulus. So they're fluffy, but they're still very thin because they have that cirrus portion to them. So if you look at the images on the right, you can see the top one, that's the cirrostratus, and the lower one, that's the cirrocumulus. Next is the mid-altitude clouds. So these are kind of the in-between. So we have what's called altocumulus. These are rounded masses. They're larger than in the high altitude range. They are more dense and they're closer together. So you can see in the two images on the right that they're still that puffy, but they're not quite as thin as in the high altitude. Altostratus, that's a white to gray sheet. It covers the sky. It's not thin, but it's thin enough to where you can still see the moon or the sun as a spot through those clouds when it shines through. And you can see that image on the right as well. Lastly are the low clouds. So these are your 3 altitudes. These are stratocumulus. So they're cumulus clouds, but they have that scalloped bottom, so it kind of looks like a bunch of cotton balls just stuck together in there. And then you have nimbostratus. So stratus clouds are low clouds. So nimbostratus, these are your precipitation makers. This is where we get rain, sleet, hail, snow. Okay. There is one other type of cloud, and these do not really have a height category to fall into because they develop vertically. So they have a very low base, but the top of their cloud can actually extend upward and end in the middle or even the high altitude. So let's recap a minute. We have high clouds, we have middle clouds, we have low clouds, and then of course our special cloud that we have that is vertically developed is called a cumulonimbus. Make sure you remember that. That's important. All right, a few more things and then we'll be done. We have fog. It's a cloud that has its base at or near the ground. So fog is a cloud. And it's caused by 2 things, cooling and evaporation. A few more things and we're done. So how precipitation forms. So you have these water molecules, these water droplets that are in clouds. They have to grow in size by 1 million times in order to fall from the cloud. Okay, so they have to gain a hefty amount of weight. Forms of precipitation. So how precipitation is formed, what type of precipitation it is, depends on the temperature of the last few kilometers of the atmosphere. So that portion of the atmosphere that's closest to the earth, that's what determines whether we have rain or we have snow. So let's talk briefly about the types of precipitation. Rain, you guys know what rain is. Drops of water that fall from a cloud. Has to have a diameter of at least 0.5 millimeters. Snow, those are 6-sided ice crystals. Snow is also very unique. Not a single snowflake is similar to another. We made snowflakes the other day in class. Snowflakes form at low temperatures, and the moisture content also has to be really low. That's important to remember when it gets the winter months. Other forms, we have sleet, which is a fall of a clear to translucent ice. You can see images over there to the right. Hail, that's produced in a cumulonimbus cloud. We just talked about cumulonimbus. I told you it was important. So that's how we get our hail. What is also in a cumulonimbus cloud? Lightning, so thunderstorms. That's why we often have hail when we have thunderstorms. Hailstones, those are the ice pellets that grow in shape as they fall because they're collecting more water particles as they fall through the cloud. So just as a brief reference, and this is our last slide for today, the largest recorded hailstone ever, okay? August 1st, 2003, there was a raging thunderstorm, pounded south central Nebraska, and it ended up leaving a lot of hailstones, okay? But the largest hailstone ever recorded in the United States fell in Aurora, Nebraska on June 22nd of 2003. It was a record 7-inch diameter and a circumference of 18.75 inches. So if you take a look at the image, those are the image of the largest hailstone ever recorded in the United States. And we're done for today.